What you're about to see is a portion of the conversation captured at Rajant's Partner Summit in Sicily in the spring of 2023. The portion we're going to look at relates to issues that customers have encountered with their new LTE networks, specifically a lack of understanding of the application needs and the struggles that LTE technology has to deliver that capacity and coverage for the proper function of various applications that require stable and reliable throughput and scalability.
Our partners and sales engineers discuss the difference between the expectation and the on-the-ground reality of LTE deployment. They'll address a common misconception in the industry, the promise of high throughput, and the actual deliverables, plus some of the reasons behind that difference. They'll also discuss the contrast between the flexibility of a mesh network and the rigidity of LTE, especially when it comes to adapting to dynamic industrial environments where change is the only constant, like mines where pits always get deeper while dumps always get higher, or ports where mountains made of containers can appear or move instantly.
Over in Australia and North Queensland, we're seeing private LTE solutions being rolled out in the mining industry at a rapid rate. You know, it's a new technology, it's the buzzword along with 5G. But now that they are getting to a stage where they've deployed the solution, they're looking at the fact of what's actually being delivered across the solution. And everyone that's been involved in mining knows they don't actually do, throughput capacity testing. They just see a technology, load it up until they reach capacity. And with LTE, they're thinking they're getting an iPhone. They're thinking the data throughput they're going to get is an iPhone, and the reality is they're not getting anywhere near that. They're not getting anywhere close.
So what you're saying is there might be an initial lack of capacity planning, or they might not know the application?
From my point of view, it's a capacity planning issue, but it's just an understanding of the technology. They've been sold a technology by a very good salesman without the understanding about how the technology works. LTE is all about downloading information, not about uploading. And we are in a business of uploading data to a centralized point to gather that information and to utilize it as it's needed. So just off the basis of that, it's reversed in the way it needs to be utilized.
So an LTE salesman not understanding the application, not being able to do application planning.
Yes.
Oh, sorry, capacity planning.
Capacity planning.
Yeah. And we've seen that like just recently this year. I was assisting one of the LTE mine sites with their autonomous truck. Now, every time that truck ran, it was generating a log file of 12 gigabytes of data per run. And they would do 10 to 12 runs per day. That LTE system couldn't upload, like you were saying. It couldn't uplink, right? So they had to stop the truck after each run and go and plug in a laptop with an SSD drive to do the download after each run. And that's just one of the shortfalls that we actually see.
Negating the whole reason for the network in the first place.
Absolutely.
The narrative you're about to hear is a common one. Solutions that appear viable in a lab or a limited test environment often fail to meet the mark when they're expanded beyond the simplicity of just one or two devices. It's a testament to the necessity of considering how technologies perform not just in isolation, but as part of a larger, more dynamic system.
Time and time again, we're seeing these new deployments go in. They want to run CCTV over it. Well, that's great, but you don't have the uplink capacity. And a lot of it's around the technology, not the overarching coverage that LTE provides, other than the capacity that the tower or the Bs that they're utilizing can handle. It's all about how much data they're doing off of that platform and what they're trying to push into the air. And when you've only got one transmit antenna, because the user equipment, the UE, whatever they've defined it as, that is going on a truck, an autonomous system, a heavy dozer, a loader, grader, a drag line, it's got one transmit antenna. It can only achieve through physics, 10, 12 megabits per second in a vacuum.
Yep.
And being a private spectrum, you don't have 20 megahertz of contiguous channel allocation like the telcos do. Yeah. You get 5, you get 10. And even if you are lucky to get 20, you're still restricted by the end user device, which only has one transmit antenna. And the salesman will spin you that it's got 2 transmit antennas and it's using transmit diversity. Well, transmit diversity is still one transmit antenna.
This is where Rajant Kinetic Mesh technology shines. Unlike LTE, which relies on fixed infrastructure, Kinetic Mesh uses mobile nodes that dynamically adapt to the application throughput needs. The mesh network optimizes the routing, ensuring high data throughput even in challenging mobile environments. When considering public LTE, especially for mission-critical applications, understand that the subscriber not only has no control over the stability of the circuit, but cannot be guaranteed available throughput. Public LTE for mission-critical data is a no-go. You've got no control of your network's availability or throughput capacity. A hybrid mesh, private LTE network is definitely the way to go for the data you cherish the most for your application demands. Contact us at Rajant and we'll make sure you get what you need.